Okay, let's take a look at this one. We're doing page 418, number 8. Okay. So number 8 says that we've got to solve the differential. It's got y prime equals x times 1 plus y. So I got to get the x's together, or the x is on one side and the y is on the other. So I'm going to change that to dy dx. All right. How do I take this entire chunk and move it to the other side? Divide it. Good. Dy, and then multiply the dx over. We're going to integrate. Do I need to use a u substitution?
Yes. No.
No, I do not have a coefficient other than a positive 1 in front of the y. So I can just get away with doing my natural log. So integrals natural log absolute value of 1 plus y equals, when I integrate x, what do I get? Over 2 plus c. All right. They didn't give me a point or anything, so I just have to get it down to y equals. In order to get rid of the natural log, what do we have to do? Exponentiate it. 1 plus y equals e to the x squared over 2 plus c. This goes away. This thing here splits into x squared over 2 and e to the c, right? All right, we've got 1 plus y. What does this become? C. And I dropped the absolute values, and that gets grouped in here with the c. And then how do I get the y by itself? Subtract the 1. So y equals ce to the x squared over 2 minus 1. It didn't ask us to solve and find the particular solution. It just said to do that punch.
What did it say?
It says solve the differential. So it didn't say particular solution. Particular solution, you need to solve for the c. Okay? All right, what else do you guys want to see? Yeah.
This test will be multiple choice.
Some of it, yes, but not all of it.
How many questions?
No, I haven't written it yet.
Are you gonna curve it?
Probably not. I'll curve it off of Zach Miller's test and Kaylee Westmoreland's test, maybe in Kiyomi Sagita's test. Whoever gets 100. All right. What else do you guys want to see?
All of them?
Well, tell me which one you want.
Number 45.
Number 45 from page 410, is that right?
Yeah, 45.
Okay.
Yeah.
Page 410, number 45. Okay. All right, so this one says that we've got to use integration to find the general solution of the differential. So we had dy dx equals x square root of x minus 3. Got to get the dx to the other side, so I'm going to do that by multiplying. So x square root of x minus 3 dx. So we're going to go ahead and integrate both sides. Okay, so now that we have that, we need to do a u substitution. This one's weird. Okay, I'm going to use this whole thing here as my u. Okay, so it's the square root of x minus 3. Okay, now I don't like that square root on there, so to get rid of it, how do we get rid of a square root?
1/2.
Not 1/2. I'm going to square both sides. So u squared is x minus 3. Like I said, this one's weird. Okay? Now I'm going to take the derivative of that. The derivative of u squared is 2u du equals dx. Okay? So now let's see how the dy is going to be y. I know that this thing here is going to just be the u, right? So u. X ends up equaling, I could solve this thing right here for the x, couldn't I? How do I move the 3 to the other side? Add it. So u squared plus 3 equals x. So for the x, I'm subbing in u squared plus 3. And then for the du, or for the dx, I'm putting in 2. I've got too many parentheses. It's going to be too much. All right, I've got 2u du. So let's simplify that before we try to integrate it. I really have u what? Squared. I could go 2u squared. So 2u squared times u squared would be 2u to the 4th. 2u squared times 3 is 6u squared du. I haven't integrated yet. Alright, so when we integrate this piece, you get 2u to the what? 5th divided by 5 plus 6u to the divided by what? 3 plus c, and then the u, I would just plop that in there. The x minus 3 square root of x minus 3. You could simplify this, I guess, but that would be about as much more as I would do with it. They're giving you 3/2 powers and 5/2 powers, so they just converted the radicals to do that. All right, what else?
Wait, I don't get what you. Oh,
No,
I did this, right? Made it a 2.
yeah.
Okay. All right, what else? We have questions in the front there? Do I need to explain what's wrong?
I forget the 2u du.
The 2u du. So the trick I used was my whole u was this square root, right? I don't want to, if I took the derivative of it, I wouldn't get what's left in there. So the way I took care of it was I squared both of them. So that gave me u squared equals x minus 3. The derivative of u squared is 2u du. Right? Right? It's all from over here. Okay? And then in order to sub back in, I subbed the u in for this part. I had to solve this thing here for x in order to sub in for the x. That's where that came from. And then the dx was this 2u du. Okay? Practice that one a couple of times. Make sure you know how to do it. Okay? All right, what else do you guys want to talk about?
38.
38 from same page?
Yeah.
So page 410, number 38. Okay. Oh, 410. All right, so 38 says we're finding the general solution again. We've got dy dx equals x cubed minus 4x. I'm going to take this and move it to the other side. So dy equals x cubed minus 4x dx. We're going to integrate both sides. So when we integrate x cubed, what do we get? Over 4. When we integrate negative 4x, what do we get? Divided by 2 plus c. So the only thing you could do to clean it up would be minus 2x squared plus c. Okay, what else? On 411. Is that right? Okay, so page 411, number 69, which was in Euler, I'm guessing. Yeah. It says to only do it with 5 steps. Okay, so they gave me y prime is x plus y. They told me y of 0 equals 2. They gave me an n of 10, but I told you in the instructions there to only do an n of 5. And they told me that the h, or the change, was 0.1. So if we start with y of 0, I've got to go y of 0.1, y of 0.2, y of 0.3. I need your help with the calculator work. Y of 0.45, right? So I'd stop after 5 of them. So y of 0 is 2. So the pattern again is I repeat this, right? Then I have to find, I take this here and I sub it into this. So what do I get when I plug in 0 plus 2? 2. And then my change is 0.1. So what do we end up with for the first one?
2.2.
And then I repeat that 2.2. I take 0.1 and 2.2 and I plug it into here, and what do I get? 2.3. The change is still 0.1. All right, help me with the calculator. What do we get for the next one? 2.43, good. And make sure you keep all the decimals at this point, okay? 2.43, repeat it, and then I take this, and I plug it into here. So what do I get when I add those up? 2.69. 2.69. Why wouldn't it be 3?
2.63.
Yeah. And then 0.1. Add that up. What do we end up with? 2.693. Okay, so we repeat the 2.693 plus we take this and plug it into here, and what do we end up with? 2 point what? 993 times the change 0.1. Alright, and then give me that answer. So obviously you'll be using the calculator, right? 9923. Okay, and then repeat the 2.9923. Take this and plug it in up here. We end up with 3 something, right? 3 point what? 3933 times 23 times 0.1, and what do you get for your final answer? 33153. 153. So at least if you had up to the 331, you'd be good on that final one. Okay. All right. What else?
13 on 429.
13 on 429. So page 429, number 13. 429. Okay, so this one we have we have to solve for the particular solution. The problem read y prime minus e to the x equals 0, and then they gave you the initial condition y of 0 equals 4. So we have to find c this time, okay, or whatever it ends up being when we integrate. I'm going to change that to dy dx. Okay, I'm going to start by moving the e over. So y dy dx equals e to the x. How do we move the dx? Multiply, good. So e to the x dx, I am integrating. Okay, and we integrate the y, what do we get? Over 2 equals, when I integrate e to the x, what do we get? E to the x plus c. Alright, I gotta get y by itself, so I'd probably multiply by 2, so 2e to the x plus 2c, which is still just what? C. Alright, we've got to get, I now at this point could probably put in that initial condition. So when I put in the 4 for the y, what do we get? 16 equals 2e to the 0. E to the 0 is what? 1. When that goes to 1. When I move the 2 over to the other side by subtracting, what do we get? 14. Alright, so I'm going to plug, I have to plug back into this. So y, not that one. This one. So y squared equals 2e to the x plus 14. It might have a square root over it. They could do this, right? 2e to the x plus 14 like that. Just depends on what the answer choice looks like. If you had to write it out, and that one is fine with the squared on it. Okay. All right, what else? What else would you guys like to see? 13? No, that was 13. Do you want to go to page 43176?
Yeah.
Okay, so 431 number 76 is logistic differential. We're supposed to find the logistic equation that satisfies the initial condition. So you've got dy dx equals 1.2y times 1 minus y over 8. And they give me the initial condition 0, 5. Okay. And then we have to put it into our P form, right? I'm gonna get there because I don't want to do it wrong. 76. Okay. So we had said instead of Y, we used P's there, right? Okay. So we had that P equals L over 1 plus AE to the negative KT. We have to get it into that format. Okay. So what is the current carrying capacity? 8. Okay. We know 1 plus AE. The current K is what? 1.2, and the negative comes from the formula times. So I've got that to start with, but I have to solve for A is what they're wanting us to do. I'm going to use that initial condition. So what am I going to put in for the P? 5 equals 8 over 1 plus AE to the negative 1.2. What's the time? 0. And that's a pattern because that always ends up doing what? Becomes 1, so it goes away. So now I'm going to multiply by 5. So I've got 5 plus 5A equals 8. So 5A equals what? 3. So A ends up equaling 3/5. We're going to plug back into this one right here. P equals 8 over 1 plus 3/5 E to the negative 1.2 T. And they left it like that. It was ugly. But that's okay.
What the question was?
It wanted you to find the logistic equation that satisfies the initial condition. When it's set up like that, you go into the logistics. So you probably need to go back into your notes and look at those two equations and make sure you understand the two equations, logistic differential and logistic. Okay, and how it's basically we get the K and the P, or sorry, the K and the L from the differential.
Do you have videos online? Are you doing this?
I'm recording it right now. Okay, and my other two classes I've already rendered for the day, so you're the last ones I have left to render. Alright, what else do we have to do?
Number 5.
There is no number 5. Oh, on the next page, 438?
429.
429, number 5? Which one?
The next one.
The next one? Page 438, number 5?
Heck yeah.
Okay. Okay, so this is our first order linear differential. dy dx plus 1 over x times y equals 3x plus 4. Okay, I'm going to rewrite that a little bit. I'm going to rewrite the dy dx as y prime. Okay? So we are now what we have is, we have a derivative, right? Do we have a continuous function of some kind? Yeah, do we have a y equals a continuous function? So that means I'm set up to have my integrating factor, okay? So remember to get your integrating factor. We take e to the integral of whatever this function is right here. So when I integrate 1 over x, what do we get? Natural log of x plus c, but we don't do the plus c. So this cancels, so what do I get for what am I going to multiply by? X. So I multiply both sides because we're doing the integrating factor, and in the integrating factor we don't use plus c.
Okay.
We haven't actually integrated the actual function yet, right? So plus 1 over xy dy equals 3x plus 4 times x dx. All right. So now we are integrating. What the shortcut on the left side is what?
XY.
The integrating factor times y. So that's this whole thing was integrated to xy. Okay?
What's the... How do you do it again?
How do I do what?
X, how do you get X
because I had the right pattern set up for a first order linear differential, I find the integrating factor, I multiply the integrating factor on both sides, and the shortcut over here is the integrating factor times y. It always will integrate to that, okay? If you want to go through all the steps, you can, okay? But you don't have to. Over here, I'd probably distribute that x, so I have 3x squared plus 4x dx. Now let's integrate that. So when we integrate 3x squared, what do we get?
X cubed.
3x cubed over 3, which reduces to just x cubed. All right, when we integrate 4x, what do we get?
2x squared.
We'd end up with 2x squared because it's 4x squared divided by 2, so it just becomes 2x squared plus what?
C.
C. And then in order to get y by itself, we just have to do what with the x? Divide by it. So we could divide all of them by x. So we get x what? Squared plus 2x. I could leave it like that. I could make it to the negative 1 power, your choice kind of, or whatever the multiple choice ends up being.
Or can we just leave it at plus C?
No, you do need the x on the bottom on that one.
Oh,
If you
Okay.
divide it, why is it multiplying them?
Huh?
If you divide C by x, why is it multiplying?
It's to the negative 1 power.
so this is when it's multiplying like 2C.
Yeah. The variable doesn't go away. It's only when it's multiplied by a number.
Okay.
Okay. All right. What else do you guys want to see
13.
on 438? Okay. So number 13, same page. We have y prime minus 3x squared y equals e to the x cubed. All right, so I got to check for my pattern. Do I have a derivative? Yes or no?
Yes.
Yes. Do I have a continuous function? Yes. Do I have a y? Do I have another continuous function? Yes. So I have a first order linear differential. I'm going to use my integrating factor.
What makes it a continuous function?
As long as it doesn't have any breaks or holes, they're going to probably be continuous, the ones we give you. Okay?
Okay, cool.
If there's no if it's not rational, right, it doesn't have a denominator, it's probably continuous.
Yeah.
Okay. All right. We have we got to do the integrating factor is this thing right here, right? 6, 4. I want to make sure that I don't use 13. I'm making sure it needs to be the negative 3x squared. So you carry the sign with it, okay? So we got e to the when I integrate this, what do we end up with?
X squared or cubed.
Negative 3x cubed divided by 3, or just negative
X cubed.
x cubed. Good. Okay, so now I'm supposed to take that and do what with it? Multiply both sides by it. E to the negative x cubed times e to the x cubed. So I multiplied in front by it. I'm going to throw my integral symbols, my dy over here, dx over here. Okay, so when I integrate this side over here, I get the integrating factor times what? Y. Perfect. Okay, over here, before I integrate it, what's going to happen with those exponents?
They add together.
They add together, so what do I end up getting as the exponent?
0.
0. So really, isn't this just
1.
1? So when we integrate 1, what do we get?
1. X.
We just get x, right? Plus c,
Plus C.
negative x cubed y. And then I got to get this to the other side by doing what? Dividing. So you've got x divided by e to the negative x cubed plus c divided by e to the negative x cubed. Are the negative x cubes happy where they're at? No. So we would probably bring them upstairs. Plus ce to the x cubed. Could they factor out the e to the x cubed?
Yes.
Absolutely. That's another tricky way they like to do the answers.
Can I use this?
Yeah, take that. Alright, what else do you guys want to see that we haven't done yet?
First one, composition.
The partial fraction decomposition. Does anybody have that problem
I don't have.
on the worksheet? Because I don't have the worksheet in front of me. Partial fraction, it was number 70.
Yeah.
Has anybody got the worksheet pulled up? 70.
Like from the homework?
Yeah, it was from the homework. It was in your notes too, wasn't it? Or pull up the worksheet, either one. Yeah, it was that little page. Yeah, what was number 70?
Number 70?
Yeah.
2 over x squared plus 4x plus 3.
That one? Okay, so let's do this. Shh. Here we go. We need to factor the denominator. So what does the denominator factor into?
X plus a number. X plus
3, thank you. X
X
plus
plus
1.
I got you.
Okay. So now we multiply by the missing parts of the denominator. So this one we just get x minus 2. What was missing in the denominator that we'd multiply by?
X plus.
Our LCD would be this, right?
Yeah.
Really, I'm multiplying by the LCD and canceling, but I'm just skipping that step because we can cancel in our heads. So we've got ax plus a. What would I multiply this by that's missing in the denominator? So plus bx plus 3b. Okay? Now I need to set up an x equation and a constant equation. So my x equation would be what?
X, AX.
Nope, without the x's in it.
1 equals a plus b.
Good. And then the constant equation would be what?
Negative 2 equals 1 plus 3.
Equals a plus
Trace.
3b.
Bet.
Okay, I would solve this one for... Oh, no, I wouldn't. I'd probably use elimination, right? What would we multiply this one by? I'd probably go -1 and get rid of the a's. You could do the -3 too. That doesn't matter. All right, so when we add up, I'm seeing -3 equals what?
2b?
This one was ugly. So -3 halves is b.
Yeah.
All right, and then if I plug back into this one here, I've got 1 equals a minus 3 halves. That's 2 halves. What's a end up equaling?
A half?
Add the 3 halves to the 2 halves.
That's like 5 and 1.
Yes. 5 halves. So that means I end up with 5 halves over x plus 3 plus, plus -3 halves over x plus 1. Or they factor 1/2 out on you. Yes.
Are these questions gonna show up a lot? Like this certain question?
There's one, maybe. I don't know. I haven't written the test yet. So I haven't decided.
Are you gonna get work, like credit for like doing the work?
Yes.
It's all the points on my page.
It's just somewhere.
No, it's not. All the points you're gonna get. You're fine. Okay, what else do you guys want to talk about?
Let's do.
What have we not done yet?
Did it say 47 on the first page?
The 47 on the first page? I don't know.
On page 410.
Yeah. Page 410. Okay, so let's go back to 410 and look at 47. So we've got dy over dx equals x e to the x squared. We've got to integrate it. Separate the variables and integrate. Okay, so what's your u gonna be? Good. So du equals 2x dx, right?
I missed.
What do I have to do with this 2?
Divided.
Divide it. Alright, when we integrate dy, what do we get? Y. E to the u. For the x dx, what are we putting in?
1/2 du.
1/2 du. When we integrate e to the u, what do we get? E to the u, what's my u? X squared plus c. Alright. I don't know, what else have we not done? Did we do all the ones on 418?
No.
No, what have we missed on 418?
No. 6. 6 and 3.
How many
Six.
Oilers are gonna be on the test?
6 and 3.
Maybe they might not, they won't be super long steps. A couple. You can do those, right?
No.
So you want more Oilers?
No, keep them on.
Yes.
Just
A
do
lot
like
of
2
Oilers.
Oilers. That's
Two Oilers?
No,
Make the whole test Euler?
please. I agree.
Just make
That's where I was like, great.
Make it like a 2 question test, and it's just Oilers.
Just Oilers?
I'm down for that. I'll pass.
Or
Alright.
It doesn't have to be a test.
Okay, what do we get? What do we do? What am I doing?
3 for 14.
3 page, so this is page 418, number 3. Okay, so we've got dy dx equals, oh, this is the weird one. So you have to take this whole thing and move it to the other side. How are we going to do that?
You're gonna subtract it.
You're not going to subtract it. Divide it. Okay, equals dx. Do I need to do a u substitution?
No.
No, so it's natural log absolute value of y plus 2 equals, when I integrate dx, what do we get?
X
Plus c. Okay. How do we undo the natural log?
Exponentiate.
I'm going to do a shortcut on the exponentiating there. So those go. We've got absolute value of y plus 2 equals e to the x times e to the c. What does the e to the c become?
C.
C. And at that point, I also drop my absolute value bars. How do I move the 2?
You're gonna subtract it.
See, we could do these kind too.
What is this called?
That separation of variables.
Uh,
They say solve the differential though. So
Are we just 6 now?
6, have we done 6 yet? Okay, so page 418, number 6. Alright, so you got y prime equals the square root of x over 3y. So again, you got to think of that as dy dx. How do we move the 3y?
you're gonna multiply.
Multiply by it, and to move the dx, we multiply by it. So I'm going to integrate. When I integrate y, 3y, I get 3 what? Over 2 equals, when I integrate x to the 1/2, we get x to the
3 halves.
divided by 3/2 or multiplied by 2/3 plus c. Probably the only thing you're going to see them do is get this 3/2 to the other side. They'll probably leave the squared on it. If they don't, just take a square root. So 2/3 times 2/3 x to the 3/2. What's 2/3 times c?
C.
Still c, right?
Yeah. 2/3. Is it 3 halves?
I multiplied by the reciprocal,
Oh.
right, to get it to the other side. So I have 4/9 x to the 3/2 plus c. Probably that I did that because you can take the square root of it pretty easily. So it could be that answer. It could be the square root of 4/9 x to the 3/2 plus c. All right. Are there any others we haven't done yet? Did we do 429? Did we do all those?
What columns are going to be chosen for the chapter 6?
I don't know. Any of them could be picked. Okay. I think we did almost all of those, didn't we? I think we did all of those on Friday. 429. Did we do number 1? We haven't done number 1 or number. Have we done number 5?
Let's do it.
Okay. So 429 really quick. Page 429, number 1. I shouldn't need to do this one. That's how easy it is. How do I move the y?
You multiply.
Multiply. How do we move the dx?
You multiply.
Integrate, integrate. What do we get for the y when I integrate? Equals x squared over 2 plus c. What do I do to move this 2? Multiply. So we get x squared plus 2c, so which is just c. You could leave it like that. It could be the square root of it. So both of these are good answers. Okay, I think for this one is probably the last one, I'm guessing. 429, number 5. So you've got 2 plus x, y prime equals 3y. So instead of y prime, I'd probably write it as dy dx. I've got to take this to the other side and this to the other side. So how do we move that?
You subtract,
Nope.
you divide.
Divide it. So you've got 1 over 3y dy equals, and I'm going to take this to the other side by doing what?
Division.
Division 1 over 2 plus x dx. Alright, we don't need u subs, because it's just 1/3, right?
Natural log.
So 1/3 natural log of y equals natural log absolute value of what?
2 plus x.
Plus c.
Exponentiation.
Yeah, I could make that, I could make this an exponent, couldn't I? Before I exponentiate it.
Yeah.
So put that up there. So we do the exponentiating. So we've got y to the 1/3 power equals
2 plus x.
2. Oh, we can't do that yet, can we?
Why not?
Because I have this plus c part. Yeah. So we have e to the natural log of 2 plus x e to the c, which is c, and then this goes away. So y to the 1/3 equals c times the absolute value of 2 plus x. I could cube both sides, couldn't I? If I wanted to. Curious if I did that right or not. 429 is section 6.3. Let's look really quick and make sure I wasn't supposed to leave it as number 5. Nope, I did do it right. Okay. I don't think, was that all of them?
I think we're missing number 13 from
I'm pretty sure we did 13. Let's look. 13, 438. 438, number 13. We did them. Okay, so the only other thing you want to make sure you can do that's on there is make sure you look at the slope fields worksheet and make sure you can match an equation to its slope field without your calculator. Okay? So probably what I will do is I'll probably go no calculator first, do the slope fields up front, and then let you have your calculator on the rest of it. Okay? Any questions?
Do the slope of them.
I don't have the worksheet in front of me. You have a worksheet that had slope fields on it, right? Alright, so everybody get into Haiku. Right now. Everybody get into Haiku. I will try to get there as well. So I should see the screens going on. And I want you to find the slope field worksheet. Okay?
It should be number 10.
Is it number 10? So it should be homework number 10. I need to go to here. Or is it 17?
10 is slope fields.
Okay. One might be the title of the notes and one might be the worksheet.
17 is the free response review.
Oh, okay.
But yeah, it is. slope
No,
fields.
why did I pick that one? I wanted Power School. Okay. Alright, so let's go to BC. We're come to chapter 6, and we're looking for around assignment 10, so it was a while ago. It was probably one that you did, there it is. So that right there I don't know if it was the answer key ever put up or no.
I didn't miss it.
No. Okay. It should be, or was it on there? Sometimes it's on there at the end. So
I printed it out and it never came up.
it didn't come up. So I would make sure that I could match these slope fields here. Okay? And match those slope fields to these four here. Do you remember how to do that? Yeah? Okay. So make sure you can, these ones you could almost tell just by looking at the picture, right? These ones here, because see how these are, see these are already in derivatives? So this is, when you get to these ones here is where you pick a point, like 0, 0, and you plug it in and test to see if the slope looks right. Okay, and we did some of those on Friday with the multiple choice. Okay? Alright. You have the rest of the period to work on studying for this test. Oh, we need to make sure your notebook is ready, right? So I'm gonna come around with the little tape, and we're gonna stick up the notebook. So you have a choice. All right, we still had the photocopied pages, right? And since I forgot to tell you to clean it up, you either can handwrite in the photocopy pages, but I don't want you to spend all night handwriting those in tonight. Okay? You may glue them in. Okay? If you don't get to either one of those tonight, at least put them in there with what you have done, okay, kind of around the first page. All right? So I'm going to start with a purple piece of tape. Find the table of contents. So everybody's going to locate the table of contents right now. Okay? Did we already glue the pages in? I don't remember.
How do you do yours?
I'll show you in a second. Okay, so table of contents, everybody's got that page. What page does the table of contents start on?
Page doesn't have a number.
Oh, it doesn't have a page number?
The numbers don't start till you actually get to
Oh,
the
the
notes.
numbers don't start. Yeah, this was the weird notebook. One of them was like that. I couldn't remember which one. You found it. Okay, so make sure it says table of contents, not the grading page, not your homework page. Okay. You're welcome. Okay, so watch how I do this. Okay, let me grab a notebook real quick. Okay, so on your table of contents page, where is the notebook? Yeah, you didn't get any? I just skipped that whole row, huh? All right. Sorry about that. It happens. Okay, so on the table of contents page, everybody's watching, right? You heard my class last year, that hasn't changed, okay? I want you to, oh, I did it on this one. Alright, so what you're going to do is you take the little piece of tape, okay, and you make it come out, right? And I want this on the side, not on the top. And then don't leave it sticky, that doesn't make sense, right? Because this is going to stay on there forever. And you make it like a little tab, so I can just pull on the little tab, okay? This is more Mrs. Ballard went to the craft store and didn't know what to do with this tape, but always wanted to buy it. So I figured out a use for it. Okay? So then I know everybody's purple tab is your table of contents. Alright, go find the first page of notes and tell me what the first page number is. What? Yeah, try to make it a fairly good size. Page 29?
Yeah.
Okay, so everybody go to page 29. I already did some of these. Okay, page 29 is going to get the orange an orange tab. Okay. Yep. You could make it a little bit bigger, but that's fine. Just stick out a little bit more so I can grab. Because remember, I want to grade fast. Okay. So page 29 is getting orange. What's wrong? I'm gonna talk with it. Give me a second. Okay. You're welcome. Wow, orange is 29. Is that right? Page 29, put this tab on it. Okay?
Same way, right?
Same way. So I'm not training you again. That's how you do it every time, okay? Alright, once you've done that, I want you to go to the first page of the notebook where it says AP Calculus BC Guided Practice Notebook. Make sure your first and last name are on there. So on the very first page of your notebook, make sure your first and last name are on there. Oops, not that. Okay. Everybody got their first and last name on the very first page? It doesn't have a page number? Okay, I want you to flip 2 pages to where it says Notebook Grade Checklist. Notebook Grade Checklist. So on the top of that page, please make sure your first and last name and period 4 are there, because that's where I'm going to write your grade, and I don't want to have to look all over for your name. Okay? We said it started on 29. And then in that first box, because I'm going to grade it a whole bunch of times, right? In the first box, you need to put, we started on page number 29. It looks like we ended on page, we did the partial fractions, so 42. So you're responsible for having pages 29 to 42 complete, and the turn-in date is 9/7/16. It is due at the beginning of class, because I'm going to grade them while you do the test. If not, they will never get graded. Okay? So while you're doing the test, I'm grading notebooks. 29 to, what did I say? 42? Yes, 29 to 42. Okay? So, if you look down that page, it says correct first page marked. We just did that, right? That's the orange tab.
Yeah.
Okay, you need to make sure your table of contents is updated. Meaning you write the title of the notes and the first page number that it appears on. Not what's on 29, what's on 30, what's on 31. You'll run out of space if you do that. Okay? Make sure you have your essential questions are done, your notes are complete, and your summaries are done. Your summaries should answer the what? Essential question. I'm probably going to skim through the summaries and make sure they're doing that, or I will ding you the last 10 points on the Cornell element. You do not need to have questions for me at this point. Okay? You just need to make sure you have your essential question and your summary done. Okay? Make sense? Alright, so right now would be a good time to make sure your notebook is updated. Don't try to come in here and be writing your summaries tomorrow. It won't work. You won't get a good grade on it. Okay? And you're just going to waste time. Likely we will try to take the test electronic. Okay? There'll still be written work, but we'll probably get the questions on haiku. Alright? Alright, I'm going to stop talking. If you want me to, I can. I don't have the new week printed yet, but I have up through week 3. Or not. I don't see you guys' clipboard. Hang on. I lost one. Let me see if it's still in my backpack. We'll apparently do that tomorrow or the next day. I fixed the clipboards home, but that's the one that didn't get it back. Sorry. We'll do stamping on Wednesday probably. I have all the other ones.
So is that one that you need is the one?
That's right. The one where they actually asked